Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
And your co-host Rich Gear here as well, and we are going to talk about the great oxygenation or the great oxidation event, depending which term you want to use. Doug, take it away.
Well, I sort of use this as an example of you wouldn't believe what an unbeliever has to believe in order to be an unbeliever.
Yeah, that is a nice way of putting that. And why do you say that, Doug?
Well, if you take a look at the origin of life scenarios that you have in the time right after the origin of the Earth, which when it formed out of nothing or whatever it did.
Gases or whatever they coalesced.
The gases collapsed and became the Earth.
That was like 4.6.
You have all the different scenarios that they have to put together to form amino acids and proteins and nucleotides needed an atmosphere that was devoid of oxygen.
Yes, and it's devoid of oxygen because we've talked about this on the show before. Oxygen is really the enemy of proteins combining or amino acids, or give us the litany of things that really couldn't really form in an oxygenated environment.
Yeah, and also waters and also
because water has oxygen in it, so that destroys anything from happening. So
oxidation is a problem for the formation of these chemicals. It disassociates the peptide bond, which brings the two amino acids together.
Okay.
And so the scenario that Miller-Urey used to produce the simple amino acids that he produced in his experiment, glycine, alanine, and I think glutamine was one of them. They're the three or four simplest amino acids. They use that to show that this was the precursors of life forming in the early Earth.
So what they do, Doug, this is like your Precambrian environment, or we're dealing with rocks here, but there's no oxygen in the Earth at this time because the Earth supposedly like 4.6 billion years ago,
right? Yeah, so
and life or the oxidation event or oxygenation event was about 2.5 billion years ago. So, but there was supposedly anaerobic cyanobacteria, is that what they call it, Doug?
Right.
That existed before this that could exist without oxygen.
Right.
And somehow, inexplicably, something switches on, some mechanism, something happens, and what happens, Doug?
Well, there's you have to then understand that all of a sudden these oceans started forming. Okay,
but oceans have water.
Oceans have water in it, so it's H2O, and so the primitive atmosphere would have had to combine the proteins outside of the water to associate the amino acids together and build the building blocks of proteins, and so somehow proteins of maybe 200 amino acids all of a sudden started forming and showing up on the primitive Earth in a solid state synthesis form.
Okay.
And if you try to do something chemically in a solid state without water, it's sort of difficult. And I tried this when I was in college. I actually had glycine, alanine, and tryptophan and tyrosine. I put them in water and added some lightning, I had a neon sign transformer. That
Dr. Frankenstein here.
And so I was trying that, and this was quite early on in my chemistry stuff. And you watch these Frankenstein movies, and that's exactly what they're trying to do, is to get these things to combine together. But I realized quickly that if you do this to glycine and alanine, well, nothing happens because they're simple. We were hoping that you'd form the peptide bonds and they would come together. Well, it doesn't happen that way, and so But tryptophan and tyrosine, well, they're a little bit different. They've got aromatic rings on them. They're pretty complicated. In fact, you can't form them in this Miller-Urey experiment that they were using.
Okay.
And so what I did was burn them. and it made this brown sticky goo.
Yep.
So I thought I had something. I thought that we were getting things, the peptide bond to form, and you combining them together to form proteins. Well, that's not what was happening, and so. The problem was I had it in water, and water is an enemy to the peptide bond. Okay, so this is a simple thing. And
well, Doug, let me ask you this question. Did they propose at some point that the oceans were made out of not water? Maybe did they like some methane ammonia?
Methane ammonia and hydrogen gas was what was surrounding the Earth, and it had this maybe sea of methane.
The problem with all that, Doug, is, if I understand it, the earliest rocks, based on their scenarios, are oxygen impregnated.
Well, that's another problem, okay?
Okay. Oops, another one. Sorry about that.
We'll sort of give them that, okay?
I know there's no evidence for methane, ammonia, whatever atmosphere,
right.
let alone an ocean. Okay. All right, go ahead.
And so, but they've also figured out that they need oxygen for life to actually get complex and support itself. And so somehow we had some of these early bacteria that were forming in their scenario also gained the capacity to produce chlorophyll. Now, if you ever take a look at the chlorophyll molecule, it's a pretty complex molecule. In fact, it resembles hemoglobin.
Oh, is that right?
Except instead of it's got porphyrins in it, and they capture a metal. And chlorophyll has magnesium in the middle.
Okay.
And hemoglobin has iron in it, in the middle.
Okay.
And the chlorophyll actually has a long side chain on it, but they're virtually similar in complexity. To synthesize these things, you guys go look it up in your chemistry books or your references, and figure it out how they would synthesize either one of these molecules, and you have one of the bases for things that'll bring life about. And so,
well, let me ask you this about chlorophyll. Does it need water to operate, or how does? I don't quite understand.
Well, it's a lot of carbon and nitrogen molecules combined together, but it also has oxygens in it as well. It has a COOH component, which is
carbon, oxygen, and hydrogen. Is that what that is?
There's two oxygens, a carbon, and it's really what makes the acid part of amino acids.
So let me get this straight. You've got basically bacteria that are anaerobic. They don't need oxygen, but somehow they begin to produce chlorophyll, which will produce oxygen.
However, they need oxygen because the amino acids have oxygen in them.
Oh. Well, we're back to square one, aren't we?
Well, we've never got started.
We never got past square zero, is what you're saying.
So anyway, but we give them all that. We set that all aside and say, well, we're going to kind of ignore all this pile of evidence.
But that's what they do.
That's what they do, yeah.
Okay.
And so we'll allow them that. And so then what they need to do is to propose that there was a great oxygenation event. It's sometimes confused with oxidation event. Now, I think there's actually two different sides to this. The oxygenation means that you're actually materializing the oxygen out of nothing.
Out of nothing. So again, we got a big bang for life.
Yeah,
out of nothing comes everything.
But okay, oxidation means that the oxygen shows a spot in the geologic record where this might have occurred, and that's where this article, Potential Evidence for the Great Oxidation Event, comes from the Answers in Genesis.
So you're thinking that this oxidation might have post-dated or the oxygenation preceded the oxidation?
That's what
not
I
by a
think.
lot, but
Right, but in order to oxidize something, you
have to have
have to
oxygen.
oxygen.
Yeah, you have to have oxygen, right.
So we have, in my mind, there's actually two different scenarios that you have to look at. And what this is talking about is that they found a place in the Precambrian rocks, which is Archean and Paleoproterozoic boundary, okay? And they found the increase of chromium concentrations at that boundary. And they attribute this to increase a chain of geochemical and biological events requiring aerobic bacteria to have evolved 2.48 to 2.32 billion years ago.
Okay, now,
100 million years ago, earlier than previously thought, according to this article.
but they just magically evolved.
Well, yeah, they're assuming that they had to have evolved because we got oxygen, and we had to do this sort of thing.
So it's because of their a priori assumptions. There's no evidence that they evolved except, okay, got this chromium strata.
Yeah.
Or whatever.
And it says this acidic environment to dissolve chromium, they say, depends upon the oxidation of iron pyrite by aerobic chemolithotrophic bacteria.
I pronounce it better.
Yeah, you did. Here, have at it there.
No, that's okay. It's a mouthful of a word. It's chemolithotrophic bacteria.
Yeah. And so
It's a mouthful.
So it's a type of bacteria that would
Chemochemical litho rock.
Yeah. It's able to digest all that stuff. And
Okay.
that's one of the characteristics of some of these bacteria you find at the vents of volcanic vents in the ocean.
Oh.
And so this is something that the people who make these NOVA videos and show these bubbling vents. And they show all
life
these,
came up from here.
Yeah, and so that's all a bunch of hooey. But if you understand anything about chemistry and what is involved in doing that, how they really are able to pull those over people's eyes is beyond me. It's people want the idea that life evolved by chance, and so they want a world that came about by chance without God, and so this is their way of doing that.
Well, see, if they could have a God that didn't apply any rules, they would be fine with that. In other words, if we could do whatever we want to do, otherwise, they got to kick them out because we want to do what we want to do. Don't you think that's kind of? I think that's kind of the bottom line of this. And they give all these like this chemolithotrophic bacteria big words to try to say like we know something, and it really doesn't explain, Doug.
It doesn't explain
how you went from anaerobic bacteria to suddenly aerobic bacteria. I mean, it's like
there's all sorts of chemical processes.
it reminds me of you need amino acids to make proteins, but you need proteins to make amino acids.
Right.
You keep getting, unless everything works, Doug, it has to work out of the chute. You can't just go from this to this with gradual steps or even leaps. It doesn't really happen in a way where you're going to suddenly make a world that's basically no oxygenated at all to an oxygenated world. Then suddenly you need things that are going to need oxygen because everything we see today, everything needs oxygen to live. Okay, but the very thing that needs it to live is the very thing that prevents from those life things from happening. Am I getting it correct?
You're getting it. You have a real paradox here for.
That's what I'm saying. I didn't get it wrong, yay, folks.
Yeah,
but it is a really conundrum, I think, for really evolutionary scenarios. I mean, right out of the box, Doug, before we ever get to, well, do apes or ape-like hominids evolve into man, or reptiles and amphibians into reptiles into birds or mammals? You can't even get there. You can't even get out of the chute. I mean, the rocks. You just can't get there from here based on what I'm seeing, what you're sharing with here.
Well, there's something else I wanted to mention is that and then this is in the current news,
Okay.
is that the James Webb Telescope made a detection of a planet or something like that out 150, I think it's 150 light years away,
Okay.
that shows a spectrum for dimethyl sulfide. And
That's a big word, folks.
Well, it's a big word, but it's a small molecule. You have two methanes sitting on connected to a sulfur. Okay. But what they're saying in this article that I just read, I think it was yesterday, is that this could only be produced by life.
Why did they say that?
That's a good question.
Okay.
How do they know?
How do they know? Okay.
How do they know that it could only be produced by life? It's a small molecule. It would have been easy to chemically produce that, a whole lot more than amino acid or a
Protein?
protein or a nucleotide.
So they're taking again another leap, which you have to do this. Folks, evolution is the most religious belief system you're ever going to find. Yes, they don't have a God that's involved in their belief system, but it's based on everything comes from nothing, i.e. Big Bang, i.e. rocks that have no oxygen, suddenly now it's impregnated with oxygen, that things that prevent combining of peptides and nucleotides and amino acids. The very thing that prevents it from happening is the very thing you need for life to exist. All of these things, Doug, are scenarios that they have to propose because they can't allow a supernatural foot in the door. So their God is basically naturalism, and this is the premise, really, of this show. If you think about it, we're just showing you the science involved in it. Really, I'm reading these articles, Doug, and it's like they're saying things. But it's just like the old adage, if you say a lie long enough and loud enough, eventually it becomes the truth to a lot of people. And this seems to be what happens. There are these people who have peer-reviewed journals, because you got all people in this little club or this little clique, they're all substantiating or verifying or basically giving you pats on the back to agree with their scenarios, which is basically the anti-God scenario. That's what I see, a lot of it. But again, everything's from nothing. And everything is based on gradual changes or even abrupt changes that don't make any sense at all from rationality. Because doesn't when we look at the genome or anything in there, the mutations or any evolutionary scenarios, if it doesn't have some kind of a use that it can retrofit or do something, it gets weeded out of the system.
That's right.
So why would this be a 2 billion year stasis? Okay, or whatever it is, basically 2 billion years or millions and millions or a billion years before, because doesn't something about the cyanobacteria, they become anaerobic to aerobic, and then they kind of sit around for a long while and don't do anything. Why would they even exist? Why would it even happen? Right. I can't even posit a scenario where that makes any sense based on their own scenarios, based on their own explanations of how evolution works. Unless it has some kind of a use, it's going to get weeded out of the genome or out of the system. It just won't work.
Listen to this. It says oxygen in an atmosphere will oxidize any developing organic molecule and make it non-biological.
Yeah, that's true.
But it says after 2.4 billion years, the evolution of photosynthetic bacteria caused atmospheric carbon dioxide to be replaced by oxygen, which rapidly accumulated for the atmosphere of oxygen.
A million years?
Here's the proposal that I have for you. Okay, if this is indeed true, why do we worry about global warming and all the carbon dioxide in the atmosphere? Because we're going to have, all we need to do is get the evolution to work and get the photosynthetic bacteria to work, and it'll completely replace all the carbon dioxide with oxygen, and it'll get rid of the greenhouse effect and all that sort of thing.
I've never understood why a greenhouse effect was so awful anyway. Plants produce oxygen. Isn't that good for us? I don't really understand. I've never quite understood that.
Carbon dioxide is good for the plants.
Yeah, that's what I'm saying. It's almost like a symbiosis between plants and animal life, you know?
Well, God created it that way.
That's what I think. Yeah, absolutely.
And, God created this. There's a whole lot of different things in the world that is a balance of everything that God created, and nothing works unless everything works.
Absolutely.
And so the scenario where God created the heavens and the earth and created everything to work all at once within a short period, you needed that. You can't have long periods because
let there be light.
Yeah,
let there
light,
be living creatures. Yep.
Living creatures, and each of the creatures need each other in order to balance the whole environment. Now, we also talked last week a little bit about the problem of sin entering the world and causing
yeah, I think that's the biggest thing, Doug, and I think that's where the young earth creation is the most viable, because long age creation doesn't really work, because then what you have is a God who's impotent or malicious,
right?
Rather than one who has judged it with the hope of redemption. And that's the whole thing about this. We're trying to remove obstacles to faith. We are not. We're full disclosure. We're not trying to hide anything there. We think the science backs up the creationist scenario way better than any evolutionary scenario. But we're not trying to run away from God. We know that we're culpable. We know the world has been broken. But there is a redemptive. There is a redemptive act that God came into human history and made it so that we could be restored. And at some point, that's going to happen fully, and we will not have to worry about sin and death and recombination of molecules.
So
and
the
aging
skeptics
and all
will
that
ask, why did God create this world where making man capable of sin? And there's a simple answer to that: is that God wanted a creature that would love him back, and to make the choice to do so rather than to be just simply robots.
And because we are a people of faith, we do accept certain things that are called axioms. Everything in nature, math, science has axioms. There are things we don't know why necessarily they're true, but they hold up and they're consistent and they're reasonable. I posit the idea, Doug, maybe the only way to get a creature that's like himself, although not himself, because he's uncreated, he's outside of time, but somebody that could be and relate to him on his thing, on his level, or you will, is for us to have to go through all the stuff. I don't know that that's the case. I don't know. It's just a scenario. It doesn't necessarily answer it positively, but there are answers to it. It's just you may not like the answer. Sometimes God gives us answers. We just don't like the answer. But in this case, Doug, we talk about the science about it. We're building this case that it's much more reasonable and rational to understand that there is a creator outside of time, outside of space, who had the information and the power, the energy and the things to produce what we see down here. And yes, it was allowed to be broken, but there will be a restoration. This is the cool thing I love about it. No,
there's something else that was showed up in recent events here that I'd like to talk about. And this is a recent discovery. I guess it was 2019 when it was discovered, but they just recently published an article about it. Is that they in Zambia, I think it was, they found some wooden tools or something like that had been preserved for a long time, and they believe that they were 500,000 years old. And
okay,
now what really I thought was really interesting was that they didn't carbon date these. They used a different method of luminous radioisotopes of rocks.
Well, they would do that, Doug, because based on their scenarios, 500,000 years old, you're going to not be able to trace any levels of carbon-14. I would like to see a lot of creationists get a hold of it, because they'll test it, and there will be carbon-14 that shows up in it. Right. But how are we going to have wood that lasts 500,000 years?
Right. Well, they said, it was preserved underwater, and underwater it's like these water logs that they don't decay, and they can last a long time. Well, 100
years.
Yeah,
a couple 100 years. I have no problem with that. But unless you petrify the logs, they're going to rot away at some point. They will.
That's another interesting thing is petrification.
Yeah. You got to mineralize stuff like that.
Yeah, petrification is an interesting thing because I saw a sign at Petrified Forest that said it takes about 30 years to petrify the
Oh, yeah? Well, that's a change. I wonder if some creations got to them.
Yeah,
you know?
I don't know, but they said that that was something that I thought was interesting, and it's true. You can petrify a lot of objects.
We've shown pictures on the shows from
a petrified hat.
Yeah.
Fossilized spark plugs that you got out of.
I think I have some of those. I think I still have one of those here. But anyway, yeah.
But anyway, some of these different things that come up in the news, you have to sort of put on your thinking cap and ask some real tough questions of the whole assumptions.
And we ask those from time to time, Doug. That's, I think, part of it is it's not. We wanted to present you with scenarios that work, not just things that are against evolution. There are things that speak to creation much more strongly. But we've talked about things, Doug. I mean, especially the dinosaurs. Mm-hmm. got my little miniature Sue over here.
Mm-hmm.
But the idea that how do you find hemoglobin? In 65 million year old dinosaur bones or collagen or DNA. How do you find any of that stuff? And I love the thing. Well, I guess hemoglobin can live 65. Before that they would have said no way. But now this is kind of reminds me of this oxygenation event. You because they see the evidence is there that there's oxygen. They gotta say this happens this way.
So they also have to propose that all of the organic material that is needed for life would have had to have been produced over the period before the oxygenation event. And so you have to have an overabundance of all this
a lot
chemical material. So anyway, I think that we have nailed the problem here, and I think you as evolutionists have to come up with some better explanations.
Yeah, don't give us just those stories. Well, it had to happen this way. They somehow from anaerobic bacteria they become aerobic bacteria. And here's the evidence here. No, you've got evidence of this chromium, whatever it is, that's in there, but you don't have any evidence of 2.6 billion years old. Suddenly 100 billion years or 100 million years before that, suddenly oxygen happened in the how did that, the mechanism for that is not even explainable. And then when you say, well, we'll get to that someday.
Right.
In the meantime, I got to exercise faith to believe that? No, I think my Creator is much more strongly tuned. I see the changes in people's lives. I see the explanation for how the world got to be the way it is. And I see a reason why it is the way it is. So that's the thing. And I really, it's, ultimately, Doug, it's a matter of your own decision what you're going to make up with all this information. But we just want to present scenarios that shows you don't have to be feeling foolish or ignorant or just a redneck Christian, because not that there's anything wrong with a redneck Christian, but just because you don't have all the scientific words. The viability of creation is very strong.
Well, I often say that the Miller-Urey experiment was one of the reasons I came to Christ.
Oh, isn't that funny?
So with that, I hope you enjoyed our show. We'll see you next time on Revolution Against Evolution.